Well, my dear participants, today I am going to talk about low level graphic function. I have already told you that high level there are two categories of graphic functions. One is high level graphic function, another one is low level graphic function. High level graphic functions always create a new plot, whereas low level graphic function add on existing plot. So among the low level graphic functions, we are going to discuss about points, add points, lines, add lines, text, add text on the graph, abline to add a line y is equal to a plus bx, abline h is equal to y adds a horizontal line, abline v is equal to x adds a vertical line, polygon adds a close possibly filled polygon. Then segments, draw line segments, then arrows from x0, y0 to x1, y1, arrows, draw arrows, then symbols and then legend. So these are the things which I would like to talk today. Here I shall begin with a data available with the book of Brown and Mudruck, and that data I have copied here. It is motor data, brand 1, brand 2, brand 3, and we are just going to copy this by using read.table, and then we are going to make a box plot of motor data. First I would like to show you what kind of shape it has. Motor. So this is the data frame, brand 1, brand 2, brand 3, brand 4, brand 5, and each brand have 6 observations. So we can make a box plot from this data in which we are using box plot motor y lab is equal to vibration, axis is equal to false, that means there is no axis, and then title motor vibration data, and then we are going to write on the margins text, m text, margin text, and the text is the effect of different bearings, and side is equal to 3, line is equal to 0. Actually side, there are 4 sides. Side 1 means bottom side, side 2 means left hand side, side 3 means top side, and side 4 means right hand side. And here line 0 means it will be just exactly, I would like to explain lines. And box without any argument, that means there is a box also. Then axis, since we have written axis is equal to false, here axis and side is equal to 2. Side is equal to 2 means on the left hand side, and then lash is equal to 2. Actually lash has an argument, lash is equal to 0, lash is equal to 1, lash is equal to 2, and lash is equal to 3, and lash is equal to 4. Here axis is equal to side 1, that means it is on x axis at 1:5. So 1, 2, 3, 4, 5 labels names of the motor, that is column names, brand 1, brand 2, brand 3. So if we run this command, what we are getting, see, title, motor vibration data, and here by using m text we have written the effect of different, and side is equal to 3 because this one is side 1, this one is side 2, and this one is side 3 and this one is side 4. So it is on side, and line is equal to 0 means exactly here just above the line. If we will write line is equal to, say for example, minus 1 or minus 2, so it will come inside the figure. So it is line is equal to 0 means here exactly above the figure. And box means it should be within the box, and then axis side 2 less is equal to 3, side 2. Side 2 means this side, axis this side, side 2 means it is the left hand side, and less is equal to 2 means it is perpendicular to the y axis. Less is equal to 2 means it is perpendicular to the y axis, and axis side is equal to 1, that means this axis here at is equal to 1 is to 5, labels is equal to names motor. So these are the labels, 1 is to 5, 1, 2, 3, 4, 5. So if say for example we write less is equal to 2, see what effect it makes. See, it has been perpendicular to this axis. It has been perpendicular to this axis. So these things we can make changes. Less is equal to 2. And if we will write less is equal to 1, it means labeling is parallel to the axis, but less is equal to 2 gives perpendicular to the axis. So these are the some of the things which I wanted to discuss here. Now I shall talk about the function points. Points is actually, this includes point in an existing plot. Say for example, this example I have taken from the manual, from the reference manual. Plot minus 4 to 4. So it is a sequence. On x-axis it is minus 4 to 4. That means minus 4, minus 3, minus 2, minus 1, 0, and on y-axis also minus 4 to 4, and type is equal to 1. Setting up the coordinate system. And then points we are adding. Points are r norm 200. So on x-axis it is 200 points are being randomly simulated from the normal distribution, the standard normal. And here also on y-axis actually 200 observations are being simulated from normal 0, 1, and color is equal to red. So it will add colors. But if we want another points r norm 100 divided by 2. So here 100 observations are being simulated, but they are being made half of the original data. Here also r norm 100 and half of the data, and color is equal to blue. CEX is equal to, here it is red, but here it is blue, and here character expansion is 1, that is normal size, but here it has been enhanced, size has been increased 1.5 times to the normal. So if we run this command, we will get the result. See, this is the result. So these are the 100 observations with enhanced sizes of the points, and these are the 200 observations which are in red. See, 200 observations from standard normal, color is equal to red, and we are adding, dividing by 2 those 100 observations, and they are divided by 2, so it is this one. So this way we can add points. Some example of points. See illustration of plotting characters 0 to 25 as in the figure shown. ठीक है. Par. Par is a graphic parameter and which sets certain, say for example, mar means margin and rip is equal to actually rip 04 means what? Rip 0, comma 4. It will repeat a vector of zeros 4 times. So it is 0, 0, 0. So here we are giving mar 0, 0, 0. That means actually these are the margins. Mar stands for margins. And margin means below the first one is below the margin there is space, 0 space. Then left side margin it is 0 space. On top margin it is 0 space and on the right hand side margin it is 4 space. So these are the margins, par mar. And then plot C minus 1, 26, 0 is to 1 on x axis, minus 1 to 26 on y axis, 0 to 1, 0, 1. So that way this will, and type is equal to n, there is no point and x is equal to false. So this will specify the region. On x axis it is minus 1 to 26, on y axis it is 0 to 1 and type is equal to n means there is nothing inside the figure. It will just fix the x is equal to false. And text we are going to add. Here it is the coordinate of x, 0 to 25. So 0, 1, 2 up to 25. This is on x axis and on y axis it is 0.6 only, because on y axis the range is from 0 to 1. So it is at 0 to, on x axis it is 0 to 25, but on y axis it is 0.6 only. So 0.6 will repeat up to 26 points, 0.6, 26 times, and then it will, and then 0 to 25 and here. So we want to write, these are the 1, 2, up 0, 1, 2 up to 25. So these characters we want to be written, and CEX is equal to 0.5. That means we want character expansion 50%, 0.5 means 50% below. And then other set of points we are adding in the same figure, that is point 0 to 25, rip 0.3 to 26. So here instead of 0.6 our y axis is 0.3. So it will be below these points, 26. Plotting character is 0 to 25. So plotting character will be, and background is gray. So we can run the command and we can get the result. See, this is because of plotting character 0 to 26 and it is on 1, 0, then here it is 0.6, 0 and then 1 and 0.6, then 2 and 0.6. So at these points we want these characters 1, 0 to 25, 26 characters. But here we want to make these plotting characters. So on 0, 0, 0 it is 0 at x axis and 0 at y axis, it is this character, and then on 1 it is circle, on 2 it is triangle, on 3 it is, and it is at the height of 0.6. Here you see 0 to 25 text and here it is 0.3. 0.6 is the height of this one, whereas here height is 0.3. So here it is at height 0.3. So these are the 0.3 and plotting character is 0 to 25. So these are the plotting characters. These are the this is 0th character, this is 1 character, this is 2 character, and these are the 26 characters. And background is gray. Background is gray. So this way we can get the result. Say for example, if we want some changes, for example, suppose instead of 0.3 we want this at 0.4 height or 0.5 height, because at 0.6 these are the characters and at 0.5 these are the characters to be printed. So it is not good, we should keep it as 0.3 and then we run it. See what changes we will see. It is near to this because it is at the height 0.4 and this is at the height 0.6. So this way we can get the result. We can get the result. Some examples of graphic par. Some more examples of graphic par. Actually, par is a very important. This sets the parameters of the graphics. Say OP output is equal to par. There are many things inside the par, like one argument is BG, background is equal to light gray. Set background, so background is light gray. And then X is equal to seq 0, so it starts sequence from 0 up to 2 pi and length dot out is equal to 51. So here if we run this command, we will get X this has length 51 and it starts from 0 up to 2 pi. So from 0 to 2 pi it makes 51 partitions and these are the points. Then what we are doing here, that after plotting these, plot X versus sin X. So X are the values and then on Y axis it is sin X. Type is equal to O, plotting character is equal to 21. 21 plotting character we have already seen. See here 21 plotting character is of this type. So plotting character is equal to 21 and BG background is par BG. BG is equal to par BG and par BG is what? It is light gray. So background will be light gray and color is equal to blue and CEX is equal to 0.6. Character expansion is 0.6 and main title of the plot is, this is main, plot type O, plotting character this and par BG and par O par. Actually if we are starting here OP, so we have set something like black light gray background, but when we were writing par OP, so it will go on original settings. It will go on original settings. This modification will not remain. So that is the common requirement in data analysis. So if we run this, see what we are getting. This is the background. Background is light gray. Background is light gray and the line color is blue. This is blue and plotting character is this one 21. Plotting character is 21 and type is equal to O. Type is equal to O means it penetrates inside the points. If we will write type is equal to something else, it will give you some other plots like, and then character expansion is 0.6. Suppose we are going to change here plotting is equal to B. That means both points and lines. So it will look like this. See here, it will look like this, B. And if we are going to have O, suppose instead of plotting character 21, suppose we have plotting character 20, then what will be the changes? See, this is the plotting character 20 which is being shown here. And if we write color is equal to blue, instead of blue, suppose we change it to red, then see what will be the changes in the figure. So here it has become red. And CEX is equal to 0.6. Character expansion is 0.6. If we are going to increase this, say instead of 0.6, say it is 1.2. See what will be the effect on plotting character. Unexpected symbol, plot sign. Oh. Now, see. So this is the extension of the, here it is 1.2 times of the normal size. It is 1.2 times of the normal size. Suppose we want green, then so it will be green, and originally it was blue. So this is blue. Suppose we want to change this main title. So what we have to write here, say for example, we want plot in double quotes, we will write either single quote or double quote, plot with CEX is equal to 1.2 and background is gray, and color is equal to color and color red. So these things, these modifications I have made, and then I would like to run this. See, plot with CEX is equal to 1.2 and background is gray and color is red. Color is not red, it is blue. Color is, here we have to change color red. and so this is the CEX 1.2. So this way we can have the main, and then par means we have to go to the original settings. So this was an example with graphic parameters and other things. Add connected line segments to a plot, and the function is lines. Here x is equal to C245, y is equal to C3356, plot y tilde x. So this will run the plot, and then suppose we want to add a line at the points x1, y1, where x1 is equal to 356 and y1 is 4, 6, 7, and lines, we will add lines x1, y1, color is equal to red. So suppose we run this plot. So this is the plot, but if we want to run these lines, see this line has been added, So this is the lines, means we want to add a line in a figure. So the function is lines. Line is low level graphic function. Now here another example of lines. Draw a smooth line through a scatter plot. Plot cars, smoothing distances versus speed, lines, stat is equal to lowest. ठीक है. Actually cars, help cars. So car is a data set which is available with the data sets package. Speed and stopping distance of cars. Description: the data given the speed of the cars and the distance taken to stop. Note that the data were recorded in 1920s. So cars format: a data frame with 50 observations and 2 variables. Number 1 variable, number 1 column is speed in numeric, and number 2 distance, numeric stopping distance, and source is Ezekiel M 1930, methods of correlation analysis. So, and that has been discussed in McNeil also, interactive data analysis. So this is the car, data car. Now with cars, plot cars and plot cars with main is equal to, since it has 2 column only, so it will create a scattered diagram. Plot cars. So because for plotting it needs one vector on x-axis and another vector on y-axis. So those vectors, cars, see this is on x-axis and this is on y-axis. By default it takes plot, without specifying, plot cars take the first column on x-axis and the second column on y-axis, distance. And then we are going to have here stat, there is no need of writing stats package. Then lines, lowest cars. So here lowest is a non-parametric method of estimating these lines. Otherwise, commonly what we do, we fit a simple linear regression line, but that should not be the good quality of fitting. It is lowest is better, non-parametric method of, if we want to fit this, so what we have to do? We have to define M1 is equal to LM and see the variable names. Variable name is dist, modeled as a function of speed, and data is equal to cars. So this will fit the data, and if we want to add a regression line, the function is abline M1, and it will add LTY is equal to 2. So here both the lines, this straight line, this dashed line is fitted by the regression method, whereas these curved lines are by the non-parametric regression, and that is Loess. So if we want to change the color and other things, say for example LWD is equal to 1.5 and cull is equal to red. So we can change the color also of the line and its width also. See. So this is the line, and we can add a legend also, which we will talk later. We can add a legend also, which we will talk later. So, well friends, now in the next lecture, I shall talk about abline and text and other things.